Hi, so this video is about the harmonics that happen when a guitar string is plucked. I realize that it can be difficult to filter through the using a software and trying to figure out what you're trying to learn at the same time. So that's why I'm making this video here in a quiet space of my own home to help you to see the different harmonics of a guitar string. Okay, so I'm just going to start with something very simple, and then we'll build up from there. So basically, in the lab that you did, if you plucked a string, you maybe heard some note that sounded like this. Or maybe you heard something that sounded like this. Good. So I'm going to put down the guitar for just a second. And you can see now in the recording, you can see there's parts where my voice was, right? I just finished speaking right here when I hit record. I hit a high note, spoke a little bit, and then I played a low note. So you can't really see a lot from here. We could try zooming in. I'll just check it out here. We'll zoom in a little bit. And you can see that there's these oscillations, right? We could count the oscillations, and we could say it looks like 14.968 or 14.972. And we could do the same trick as we've done before and actually figure out what the frequency is based on counting the number of oscillations. But I'd like to do something a little bit different right now, which is I'd like to take a look at the sound spectrum directly. And so what we can do here is I can, for example, this is our first note, the high note. I'm going to capture everything, or most of it at least, and then I'm going to go to Analyze and plot the spectrum. So what you're looking at here is a high peak at 322 hertz. It says it's an E, and that's actually good. That's telling me that my guitar is actually tuned, because I was hoping that I had my guitar tuned. In fact, maybe if you've played guitar before, you know that the tuning is E, A, D, G, B, E. There's like a few mnemonics out there, such as Eat at Dad's Great Breakfast Eatery. It's the first letter of each of those. And so the E there, this E4, is telling me that my guitar is actually like pretty well tuned. And so that 322 hertz is the frequency of that high string. Let's take a look at the next one. The next big peak happens at 643. Now, I have the calculator over here on the side so we can do a few things. I can look at that number, and if you notice what I'm looking at when I do this is, sure, the cursor's moving around, but what I'm looking at is this peak number down here, the one that kind of locks on to 643, even if I hover around a little bit here. So you can see I hover around, and then down here, this peak value is still staying at 643. So if I do 643, and I'm going to divide this by, over here, it looks like the peak is at 322. It looks like I get 1.997, right? That's pretty good. If you're not familiar with this E notation here, I'll just change it to kind of a general notation here, and maybe I'll take off some of the, we don't need quite so many digits of precision. There we go, 1.997. So that's interesting. That must mean that this one is a second harmonic compared with this one. Let's take a look at this next one, 966. Well, 966 divided by the harmonic, 322, whoa, it's exactly 3.000. So there's no question, this is the third harmonic. Let's take a look at the next one. The next one is at 1282, okay? 1282, and if you know something about music, you can actually see this thing is saying that it's an E6, which means that you're expecting it should be 2 octaves up from the fundamental, which is E4. And sure enough, if I divide this by 322, which is again, just reminding you that the frequency of my fundamental here is at 322, if I divide that, I get almost exactly 3.981. So I'm getting now the fourth harmonic. Let's take a look at what we guess might be the fifth harmonic. This one here is 1611. So 1611, oops, divided by 322. Wow, it's 5.003. Let me take a look at the next one. 1931. 1931 divided by 322, 5.997. So, and so on and so on. We can keep doing this, right? Let's take a look at this peak over here. This peak over here says it's an A7, which is at 3548. So let's try that. 3548, oops, divided by 322. Wow, it's the 11th harmonic. So hopefully what I'm trying to convince you of here is that all of the harmonics are happening all at the same time. That's kind of the punchline, right? Is that you pluck a string and all these things are happening all at the same time. But this is the one that you kind of hear is this note, right? The one that you would hum along to. But the rest of these harmonics, the rest of these frequencies, twice the fundamental, 3 times the fundamental, 4 times the fundamental, etc., these are all what make this thing sound like it does. So, going back to our manual here, you can see this is our kind of equation here, is that the frequency of the higher order modes is going to be n times the fundamental frequency. And here n can be 1, 2, 3, 4, 5, all the way up to 11 as we found out. Okay, good. So now I'm going to go to that next note that we played. Now this one, there's me talking, and this is that next note. I'll zoom out a little bit so it looks a little more familiar. Remember we played that first note, I said a couple things, and then we played this second note. This was the lower note. This was actually the lowest note on the guitar. It should be an E3 if my memory serves me. And if I bring my cursor over here, well, let's see. It's also saying it's 322. Why is that? Why is that? Did I make a mistake? Oh, indeed. Huh? Okay, so after some thought, I realized that this effect is going to be easiest to see with the higher notes looking at these harmonics. The places where the tension of the higher is going to be good approximation for this being like say close to the theory that we've talked about here. So in other words, the higher the note, the more this sort of corresponds to this actual situation here, which is why we'll try to use some more higher tension strings and hopefully get a better result as a consequence. So let's see, let's talk about a few more things here. So I'm going to go ahead and close this out again, and I'm just going to play through the different notes of a guitar. So you've seen that high note, right? So that's me talking. This is the actual high note here. Whoops. This is the actual note that we played. Again, going back to analyze, plotting the spectrum, you can see that I've got something like around 322 hertz, and then I have the 645. That's the second harmonic, third harmonic, fourth harmonic, looks like fifth harmonic, and so on. And so we've seen these mathematical relationships now. The next thing that I want to show you is that we can artificially suppress the harmonic. So in other words, if I place my finger at different places, so I'm going to actually go to spectrogram, and I'm going to change the settings here. I'm going to make the window size be 8192, as we typically do, and I'm going to zoom in here. Oops. So zoom into, let's say something like this. That looks good. And I'm going to play a low note, a higher note, a higher note, so one of the things that you can notice here from looking at the spectrogram with me is that we can take a look at the data, and that lowest note that we saw, that was producing, the whiter it is, the stronger the sound it is. And it looks like here, this is just at the level where the microphone can actually register, which is why it was a little bit confusing for these lower sounds. But then we go higher and higher and higher and higher and higher, and you can actually see sort of an upward cascading, both of the fundamental as well as the higher harmonics. So you can actually see these things, and also notice, for example, let's take this middle one here. You can see that the frequency is somewhere around, let's say 150, something like this, whereas the next one is somewhere around 300. So this must be the second harmonic of this. And here, this is closer to around 450, so it's the third harmonic, and so on. You can actually zoom out a little bit more, and you can see that there's even more harmonics, right? So it almost looks like a ladder of different frequencies, right? And again, if I were to take a snapshot, let's say I grabbed this and took a look at this at the actual spectrum, you can again see here 139, 280, 417, 573. This would be the fourth harmonic. So you can see this is a D3 and this is a D5, so that's exactly 2 octaves up. So if you go from a D3 to a D4, that's up an octave. And so if you go D4 to D5, also up an octave. So anyway, so that's one part where you can see the changing frequencies. And then the other part I want to mention is that let me, yeah, okay, I can do this still as a spectrogram here. I'm going to go ahead and keep hitting record. And this time I'm not going to talk. I'm just going to simply play the fundamental, the second harmonic, the third harmonic, and the fourth harmonic of that lowest string. Good. So hopefully what I've convinced you of here is that if this is our fundamental, you can actually start to see, do you see a couple of things here? Let me just point out the most important features. One is that this lowest one, the reason you don't see it so large is because of the actual microphone itself is not picking it up as much. But this is still the fundamental here, around 100 or so. And then you have 150, you have a 250, it looks like around a 350. So these are all multiples of this fundamental here. This is our second harmonic, which actually happens to be the next here. And then our third harmonic is the same as this one here. And our fourth harmonic is the same as this one here. So you can actually see the ladder that I've created and then the fundamentals that follow it. Let me start with a higher note and see if that becomes a little bit more obvious. Okay, so here I started with this note here, looks like around 150. We can verify that by taking a look at plotting the spectrum. You can see that that fundamental is around 144, and there's harmonics, a second harmonic at 280, a next harmonic at 424, and a next harmonic at 568. And if we look here, the next harmonic that I played by lightly placing my finger halfway across the string, so think this picture here. I placed my finger exactly halfway across the string. I excited the second mode or suppressed first mode stuff. So I was really hearing second mode, fourth mode, etc. And so you can actually kind of see this here, that the spacing is more. Then I placed my finger 1/3 of the way, suppressing the second harmonic and looking at the third harmonic. And that's this peak right here. And you can actually see that if we look at the spectrum here, we can see that this one has a peak here at 198 and 425. And so that big peak at 425, that is this same as this one right here. So in other words, there was a little bit, I didn't fully suppress those other ones, but I basically got the main effect, which is that I excited the third harmonic here. So the third harmonic is actually minus 26 dB compared with minus 36 dB. And as we'll learn, that means it's approximately 10 times louder because it's almost 10 dB louder. And then finally, we have our fourth harmonic, which is, if we look over here to our fundamental, 1, 2, 3, 4. If we go all the way across, that's the lowest note of this one. And so again, we can do analyze, plot spectrum. And our biggest peak here, which is maybe a minus 27 dB or so, a minus 28 dB, is at 572, which actually happens to be the fourth harmonic of this fundamental note. So when we do this fundamental analysis here, we go fundamental, 2, 3, and then 4. The fourth harmonic is 568. So 568 versus 574, I'd say pretty darn close. So again, I'm making these harmonics by lightly placing my finger on the string. So it's actually fundamentally different than actually making the string effectively longer. So there's one effect, which I can do this. All of those were done by pressing my finger down firmly. And so that was effectively making the string shorter and shorter. And as I did, you can actually see the stepping up of staircase here. But what's interesting is that also the spacing between notes gets larger too, because if the fundamental is larger, then that means that n times the fundamental, right, that is actually going to be larger as well. So anyway, that kind of concludes our concepts here today about guitar string. Thank you for watching.